So for example number 4, it's similar to example number 3, although we have a slight variation of the problem. We have A, which is a point out here, and then we have a point B, which is right here. So, and then we have a triangle that forms, and we're trying to determine the same thing. But we're told that from here to here, this is 80. Okay, and then this is 50. And then in the diagram it says the length from here to here is r, and the length from here to here is r. And so they're saying, is AB the tangent of circle C? Okay. And so it's just like the other problem, except we have to identify what's what. So this is not perfectly drawn to scale, but we need to determine if this is a right angle. Now the way that I've drawn it, I didn't do the best job, but we can see that it kind of looks like it is, so we have to verify it. So that means we're going to apply the Pythagorean theorem again, a squared plus b squared equals c squared, where c squared is the hypotenuse, always. And the hypotenuse is always across from the 90-degree angle. So we need to see if this is the 90-degree angle. So c, in other words, c, lowercase c, has to equal 50 plus r. Because this, in other words, we're identifying that this would be the hypotenuse. Okay? So when I do that, a then, it doesn't matter which is which. So this could be A, and this could be B, or vice versa. So another way to look at it is I could say AC. In other words, we identified that AC is the C part. So I'm going to say the line segment AC squared should equal BC squared plus AB squared. Well, what is BC? Well, BC is just r. Lowercase r, it's the radius of the circle. AB, on the other hand, is 80. Or no, yeah, no, it's 80. I'm getting confused here. When I did this on my notes, I wrote them backwards. So, and then AC from A to C is actually 50 plus r squared. And I'm going to rewrite that because we're used to seeing it like this: r plus 50. Well, this is pretty easy. This is r squared plus 80 squared. 80 squared is just going to be 6,400, I believe, right? 80 squared. So that's 6,400. And we want to see if it equals whatever this is squared. And then we need to solve for r. So what I'm going to do then is I'm going to multiply this out. So to multiply this out, remember that r plus 50 squared is the same as r plus 50 times r plus 50. So r times r is r squared, r times 50 is 50r, and then r times 50 is also 50r, and then 50 times 50 is 2,500. In other words, this thing squared is r squared, and then 50r plus 50r is a positive 100r, and then 50 plus times 50 is a positive 2,500. Now, that might be a little confusing because we have some quadratics, but if I subtract r squared here and I subtract r squared here, okay, these two cancel and I'm left with 6400 is equal to 100r plus 2500. So now I'm just going to solve for r. So I'm going to subtract 2500 from both sides. And 6400 minus 2500 equals 3900. So I get 3900 is equal to 100 times r, divide both sides by 100, and I get 39 is equal to r. Actually, I wrote the question down, not quite. I think it was, is AB tangent to C, but I think what the question would really be better is, what does the value of R need to be for AB to be tangent to C? Okay? So the question, I wrote it down wrong out of the book. So let's rewrite that. I haven't had my morning coffee. So what is the value of R so that AB is tangent to circle C? And then we would say R must equal 39. In other words, if the radius of the circle is 39, then that'll make AB tangent to the circle. Okay?